Given that A and B are numbers representing arcs or angles that are in the first quadrant, and sine A equals 4/5 and cos B equals 12/13, find the exact values of cos A plus B and cos A minus B. Right, so we're going to have to use the formulas for cos A plus B and cos A minus B. They are in here. Both of them, you're going to need to know sine and cos of A and B. Right now, we know sine of A and we know cos of B. So we're going to have to find sine of B and cos of A. And the way to do that is to use the Pythagorean identity and to remember that we've been told it's in the first quadrant. In the first quadrant, everything is positive. Sine, cos, and tan are all positive. So the first step, from sine A, work out cos A. From cos B, work out sine B. Okay, so sine A equals 4/5. Square both sides. Sine squared A equals 16/25. Now we can substitute. We know sine squared A plus cos squared A equals 1. So sine squared A can be written as 1 minus cos squared A. So 1 minus cos squared A equals 16/25. Make cos squared A the subject. So cos squared A equals, well, it's going to be 1 minus 16/25. So you could write 1 as 25/25. Minus 16/25. 25 minus 16 is 9. Cos squared A equals 9/25, and cos A, and it's the square root of that, and we were told everything's in the first quadrant, so we know it's positive, so it's just 3/5. So we're going to use that later. But first, we're going to do something very, very similar using cos B, and we're going to turn that into sine B. So cos B equals 12/13, square both sides. Cos squared B equals 144/169. Do the substitution, Pythagorean identity, 1 minus sine squared B equals 144/169. Make sine squared B the subject. Sine squared B, well, it's going to be 1 minus 144/169, so that could be 169/169 minus 144/169. You don't need to do that. You could just literally count on from 144 to 169, see how many you need. I'm sure that'll be easier once you do enough of these. Anyway, it's 25. 25/169 equals sine squared B. So sine B is going to be the square root of that. We know it is positive because we know it's in the first quadrant. So sine B equals 5/13. Okay, so what we've been asked to do is work out or find the exact values of A, cos A plus B, and B, cos A minus B. So if we look in now, cos A plus B is going to be cos A cos B minus sine A sine B. Cos A minus B is going to be cos A cos B plus sine A sine B. Part A, cos A plus B equals cos A cos B minus sine A sine B equals, and then we just put them all in. So cos A, we said, was 3/5. Cos B, just go up. Cos B was 12/13. minus sine A was 4 over 5, and sine B is 5 over 13. So 4 over 5 times 5 over 13. So that is going to be 3 12s are 36, 5 13s, where you can do 10 13s, 130, and then half it, so that must be 65, minus 4 5s are 20 over 65. So cos A plus B equals 16 over 65. And then for cos A minus B, well, all that's going to change, if you look at the formula, is this bit here. So we just need to, instead of subtracting, we just add them. And everything else is done. So for part B, cos A minus B, definitely not going to show a whole substitution. It's going to be 36 over 65 plus 20 over 65, and that is 56 over 65.